if the cylinder is given and point is given somewhere like this red point in front of the cylinder, A point. So point, okay, point lies on top surface of the cylinder. Okay, so top surface wall of the cylinder. How it show in the orthographic view? Line like this, and we need to draw. Okay, so this is a front, that's a top, and that's a left view, left hand side view. So where is A? A is at the center somewhere, at the center of the wall of the cylinder. Okay, so the top surface of the cylinder somewhere here. Okay. So how to write it here? So if in the 3D space, so that is a 3D. That is in the 3D we are using capital letters. Okay, so letters are capital. But in the two-dimensional space in orthographic view, so we are using small letters. So I have to write it here with small character. Okay, so A dash. In a front view, we are using 1 dash. Okay, so 1 dash. In the top view, no dash. In a left view, we are using 2 dashes. So where is that A point in other views? You might have that kind of question in the examination also. So where is A dash in the top view? So that A is in the middle, so you have to project it vertically. So that will be here. Will be here. Okay, so that is point A. So where will be this one in the left view? Left view. So have to find it, where is A. So same rule, like you can make 45-degree angle and make this one when it meets with that line, and then go up, and then get from here that the level. Okay, so that distance, this distance, and or you draw a horizontal line like this, and then when it meets, so that will give you the point A2 dash. Okay, so another thing, just make a line. Sorry. And without having that this kind of drawings, just we can understand this is there. This is there, and that's a point A2 dash. Okay. So if you have a bracket, what will happen? So if we have a bracket here, bracket A, so what will happen? So bracket A. So where is the location of bracket A? Bracket means that is behind, on behind of the surface. Okay, so not on the front, that's on behind. So this is not true then, not true. So the behind is here, but same position, same. So you need to make a same projection. Okay, so to this side, the center, and then A will be there. So how will be in the left view? So that's wrong. Same position, same position. A will be A2 dash will be here. Okay, so that is when it's in the middle. So how about in other place? If do you have any question about this?
No.
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 Okay.
No
So
question.
it's easy, saying it's you would understand.
How we know that dot A is behind the cylinder?
Okay, so if you have a character without any brackets, that means in the front. If you have a brackets, that is on behind. Okay.
Okay.
So I delete this. We don't need this. Thanks. Okay, so now I will make a point somewhere here. So where will be this point located? So in the question you will be given like, okay, so note is the point is always on the surface. Okay, so outer surface of the cylinder, not inside. Okay, so it's outer surface every time. So how I get the projection? So I will make a line from this one, like this vertical line to the top. And okay, so I'm looking, is it in with bracket or not? So if it's not with bracket, that means it's in the front of the shape. Okay, so from the top view, if you see, that is in the front. So that is A. So this is a vertical line and horizontal line. So that will be somewhere in the left view. That will be on the horizontal line, but not in the edge. So if you see A here, so then that will be on the edge. But it's not on the edge because it's somewhere else in between the edge and the center line. So everything in this corner appear inside of here, because we don't have a bracket. But if you have a bracket in here, so then that will be somewhere here, so with bracket, and everything in green side appear here. Okay, so if this one in the bracket. Okay, so now what we do is we measure the distance. We measure the distance of this, or just you can make a line in 45 angle line, and when it meets, just you can go up and then find a point. So but I recommend you to do not do that one, and do not spend your time and just measure that distance, green distance, and make a line with that distance. Make a line that put that distance here from the center. Make a line. Okay, so and when you get this point, so that point is A2 dash point. Okay, so this distance should go there. So if you have dash here, so the point will be, A point will be here, and from here you need to measure that distance, put that distance here, make a line, and make a point here. So then A2 dash point will be here. Okay. Okay, so you understood, right? So another question, another example. Do you have any question about this? So in case of if there are no if the point is given in here, not in the front view, so what we do, if the point is given somewhere here, point A, and how you find it? How you find position in other views? So how you find a position in front view and left view? So just draw like this line, okay, and so it will be on this line, okay. So the point somewhere will be lies on this line, but we don't have a height information. We don't have, it's not given, but you have to put any position, any height, and you need to show the point with small letter, but with dash. Okay, so and we are making like this line. So that is somewhere in this side. Again, you need to measure that distance. Put that distance. Okay, so this is a center. So from the center side of the center, put that distance, and then draw a line that will be in the intersection point of that two lines, and A2 dash will be somewhere here, but that is on behind, so that's why we have a bracket. Okay, so like this. So another thing, okay, so if you have no question, so another example, another important example. So we need those points, we need that point also, and that lines. So in case of a given kind of a cone, So cone is given, and a point A is given somewhere in the middle. So point, this is a big capital letter, okay? So where is this point? So let me draw the cone shape, triangle. Okay, so the A point is somewhere here, A dash, and so the point will be in here in the top view. So that is A, and on the side will be here. That is 2 dash. Okay, so everything is fine now. Okay, so if A point is not here, what will happen if the A point is somewhere here? So what will happen? Again, we have to make a line, but we cannot do this one because we are seeing here the base of the cone. So it's not on the base. What will happen? So if this one is in here, so then in this case, we can make this kind of line and we can put as a cylinder, like a cylinder case. It's not here. The point is not here.
English, please. Sabar.
Okay, so in this case, we need to make a line passing through the from the tip and passing through that point, and then we can get this point on the base. Okay, so then we use that base point location to project it to the top face. Okay, so top view, and we're making another line. From this point up to the tip. Okay, so that means the projection of this line is this one, this line. So where is that point? Point A dash. So A dash point is in this line. So that's why the projection also will be on that line. So we're making a projection with using a line like this to find point A in a top view. Okay, so and on the left view, on the side view, will be same thing. The distance, we can measure the distance. So that distance, we measure and we make a line. And the location of intersection point will be the point A2 dash point. Okay, so similar thing. Did you understand this? It's easy thing. This is first way. The second way is cutting principle. So how we do with cutting method? So with cutting method, we are cutting. We're making a cut from this point location place. We are cutting the cone, and we're making a truncated cone. So something like this. So then the point location. So point is located on the edge of this upper face of the truncated cone, upper base. Okay, so point A is located on this edge. So same thing happening with the projections. So we are cutting this triangle. So we don't need this kind of slope line passing through the center. We don't need it. We don't need the point on the base. So point A dash is given. So we are cutting. We're cutting with a plane. So what we'll have when you cut this one, so you need to find this point. Okay, so we need that point. So where is that point? So that point is here and there. So green one. So we are making a projection of that point to the top view. So here, and we're making a circle. Okay, so we are drawing this edge. So so A point lies on that edge. Okay, so that A point lies on the edge. So that's why to find the edge is important. Here the edge of the truncated on upper edge, and we project the point A, red point. Okay, so A dash point to this edge. Then the location of A is there is a no bracket, so that's why it's in the front. So the point A is here. Okay? It's not a green. That's a red dot. That's point A. So same like another example. So other side, you can measure from this distance and make a distance of from the center line and find this kind of projection in to find A2 dash. So that is second way. Okay, so that is cutting or second plane cutting method. Okay, so that is second way. So it's easy thing. Another example is opposite way. So in our case, I gave you the front viewpoint and find in other, okay, in the top view and in the left hand side view. In case of the point is given in the top view like this. Okay, point is given here. So what will happen? So you need to make a line passing through this top corner, okay, top peak of the cone. So like this line. Okay, so we can get an edge. So from that edge, we can transfer that one to the upper view, and from the upper view we can make the line passing through that point to the tip, and we can project that point to the up. So here that point is. Okay, so this A point is given, so we found A dash point, and also by using that 2 points A and A dash, we can try to find A 2 dash point. Okay, so by cutting method also similar. If the A point is given, okay, A point is given, how to find its position. So you need to make a circle passing through that point and center of the cone, okay, and you can make a like this line. So find that edge points, okay, so that point and that point. Make a horizontal line. So that's an edge, that means edge front view, and project your point onto that line. So make this point smaller. And the red point is here. It is A1 dash point, this red one. Okay. So that's a point. Okay, so that's a way. So that's a red. Okay, green one, green points projections. That's a red one. And then you can find by using that 2 points, you can find the third one. Okay, so make a line and distance line and draw the line and find that point. So that's a way I'd like to show to find the points. So do you have any questions about these examples? Sorry. So do you have any questions about these examples?
No.
Okay. I hope you understand about this example. So this will be, I think, included into the examination. It might be easy things, but to find the points is very important. If you know these techniques, you can draw very complex shapes also. You can find easy way to solve any complex problem also. Okay, so on last lecture we studied those things like this kind of examples. So the first is how to find a point is using a secant method. Okay, so with cutting method, we are saying like we are making a plane here, just invisible plane, and we are cutting this. So when you cut with plane, okay, P or any plane, so what we have a like this section. Okay, so that section, so that point lies on that section, so we are finding that point and then we are projecting to other views. That's a secant method. Okay, so that calls secant method. Secant method, or it calls a cutting method. Okay, cutting with plane method. Okay, and auxiliary plane method, different name. And the second method is making a line. Okay, so the line method. So we are making a line from the tip, if the cone or if the pyramid shape. Okay, so we are making a line passing through the tip and also that point, and the line should make a point on the base of the shape. Okay, so the base is this one, so base and that one. So on the base we are making a point, and we are generating the line in other projections, and we are making that point's projection on that line. Okay, so that is a second method, the line method, second method. Okay? And another method is same like the first method, like second method or the plane cutting method. So we are cutting the with plane, so we are making the plane, and so that plane makes this kind of section. So the point C lies on that plane or on that plane or on that section, so on the edge, so we are projecting that one to here. Okay, so or the way is the opposite way, like we are making a, so the point C dash is given here, so we are making a circle, so we are finding this edge of the circle, and then we are finding that point and another projection, so we are making a line, so that means that edge. Okay, so and that point lies on that edge, so we are projecting it to that edge. Okay, C dash, so C2 dash. So those things studied on previous lessons. So let's continue. So same thing happening with pyramids and prism kind of things. Okay, so make a line from the tip or make a cutting. Okay, so here two prisms are the prism and pyramid is two bodies are intersected or penetrated into other, and then we need to find the intersection lines. Okay, so this is studied in previous lessons also. And intersection pyramid with plane traces, how to find the intersection line. So this one, so let me show. So this trace is given. Okay, so this trace is given, that means a plane. So plane is given with plane traces, and we need to cut a pyramid. So how to find this surface or that lines? Okay, so this intersection lines of the pyramid. In other views, so those plane. And here another example. So this is example 1. That's example 2. So this area is generated after cutting of pyramid. Okay, so how to find? So we are making a okay, the plane, and we are finding the points. Okay, so this L, M, and K points. But how to find? So only these traces are given. Traces are given. So we are using a, first we are using this tip S dash. Okay, so this tip. By using this tip, we are making a line. Okay, so we are making a line, finding this 2 dash point. Okay, 2 dash point. So passing through this tip. Okay, passing through this tip, and so trace is made at 2 dash point. So we are finding this 2 dash point, and then we are making this line. Okay, so that line. And what else? So we need to find these points L2 dash, K2 dash, and M2 dash. Okay, so the how to find it. We need to make a, okay, so here the pyramid's edge is given in the beginning. Okay, so that edge can be find at can generate this 3 dash. So we are cutting like this, and we need to find that point in the front view plane. Okay, so that 3.3 dash made it this 3.2 dash point. Okay, so and then we are making parallel line parallel to this trace, and making this this kind of line. Okay, so that will generate K2 dash and L2 dash. Okay, so that is 2 points. So we are making a projection on the bottom. So those points. Okay, so that is in one edge. That's another edge. Okay, so here is L dash and K dash. We are making, okay, connecting them, and making this line. Okay, so that this line. And another line, how to generate M dash point here. So using the base line. Okay, so base line is given like A dash and C dash. So that line will be a parallel line. So this one and that one parallel. So that's why from both, okay, from this side we can make a parallel line, and until it meets in the point M dash. So that will generate M dash point. So then we can connect M dash with L dash. So that will make this kind of another triangle. So this L point then, okay, so that is a top view. So the third view can be generated by using front view and top view. The third view can be generated. Okay, so that's a way. Another way is on the right hand side, the second way. So a trace is given, and we can make a line perpendicular to the trace, and we'll project everything on the the pyramid, everything to that line. Okay, so we are making parallel lines to the trace, or just we can generate 1, 2 dash point, and we'll project it in here. Okay, here, and we will find this point, and so we'll measure that distance and put there. Then we'll generate this the trace true shape of the trace. Okay, so upper trace, this trace can be generated here. Okay, so then that line is a kind of a true shape of the upper trace line. Okay, so what else? So we are making every projections on that one, on from A dash, B dash, and C dash, everything, and from S dash, we are making a measuring from here, for example, for S2 dash, everything, and then we put here, and A2 2 dash is here, and B1 2 dash is here. So then we are finding L points, right? L1 2 dash and M1 2 dash point here. Okay, so we can measure those distance and put its own position. Okay, so we're finding this point, and we're finding that point here by measuring the distance you can put there, and just directly you can find a crossing point, and K also, like you can find a K point here, like project it here. You can find a point here, then upper position, find it. Okay, so then you can generate, by connection of these points, you can generate the crossing plane or intersection plane. So here, okay, so that the way is like that. So if you have a question, just ask, and we can discuss about this. It's easy thing. Just you have to look, and if you have a time, you can do yourself the first one and second one, so you will understand it. But if you do by yourself, okay. Another thing I'd like to show you is this one. So intersection of pyramid and prisms. Like the pyramid is given, and prism is given, and prism position is not in the center. Okay, so in previous examples, the prism was at the center of the shape, but this one is a little bit on the side, and so how to do this? So we have to select a point. Okay, first we need to select a point in one view. For example, this one, the point on the edge, and also on the view from the side of the prism. So you need to find that view. Okay, so one of the shapes should look to you like perpendicularly. Okay, so like a true side of the shape. Okay, so in this case, in our case, it's a front view. In different examples, it might be in different views. So you have to select this kind of view and make a points. Okay, so point 2 and 7, point 1 and 6, and point 5 and 10. Okay, and make a points here, there, several points, and then try to find that points in other projections. For example, as I told you in this kind of examples, you can use line method. So create a line. So make a red line like this. So from the tip and passing through point 3 and 8. Why is 2 points? I will tell you later. Okay, so just say third point and second point, first point, fourth point, and fifth point. So we are making a line, red line, passing through the tip and point 3, the blue point 3, and find G and H. Okay, so G and so G and H, this one, point. Project, okay, where is that point? That point in the base of the pyramid. So find that one by projecting it on the pyramid base. Okay, so that is on the top view. Okay, so that point. So make that point here and create a line passing through that point and a tip. So tip is here and here also, right? So from the top view. So make that line. So that and find a projection of the point 3 projection on the top view. So just project it. So that is here. Okay, so because the shape is penetrated in going inside and outside. So that's why it makes 2 points. Okay, so the first inlet point is 3 and outlet point is 8. So inserted point is 3. So and the going out in the point A. So that's why we did 2 points. Okay, so same like first one and sixth one. So first one is here, inlet point and outlet point is sixth one. Same other points are same with using lines. We can create points like so in case of 4 and 9, we don't know where is the location. So how to do is you can get from here. Okay, so second point is here on the left hand side. You just refer that value, the distance. So then that distance you can put it from the center, put it here and find it. Or other way is make 45-degree angle and go that way and go to the left hand side until it meets the edge. Okay, so in that way. So same way, with the same way, so try to find every points in every projections. So then and connect them. Okay, so connect the points like here second point and first point is connected. So second point, where is the second point is here, the first point is here. So you can connect them like this. So second point and the third point in the top view, okay, front view, second and third is connected like this. So second and third on the top view, you can connect like that. Okay, so and the shape is given like this. So this is outside. So all other thing will be on behind, okay, in the bottom. So that's why it's invisible. So that's why you can see it's made it with hidden line like this. Okay, so everything is under the this triangular prism is made it hidden. Okay, so you can do everything under this shape hidden. So to understand, you can paint it. Okay, so you can paint it up with using just a transparent color. Okay, so do not make very dark. So just you can make transparent line to show outside what's behind or what's the bottom. Okay, so on the left hand side we also similar. So the shape is in our side. Okay, so the outside is made it with hidden feature, hidden lines. So that's the way. So that's a way of generation. There was a question. It's a little bit confusing. Yes, it's a little bit confusing, but we need to understand this one. So that's why I'm asking you. Please ask the question. If you do not understand, I will repeat it. Okay. So the task is like this. So let me show. Okay, task is like this. So you will be given a two bodies intersected bodies. So you need to find intersection lines. So these lines are not given. Okay, so these points and these lines are not given. Just imagine the pyramid is given like this, and then this kind of prism is given. Okay, so prism is penetrated. Okay, so pyramid is given and prism is given, intersected prism. So and then other views are given also. So that from the top view, this kind of the pyramid. Okay, so four-side pyramid, and then prism shape is given. Okay, so and third side also given same. So without any intersection points, how to find that intersections? How to find that intersection? So firstly, we do a points. So select a view which is the prism side is projection. Okay, so front projection to you, like perpendicular perpendicular to you. Like this side is perpendicular side to us. Not all other sides are perpendicular to you. So here is this side has a slope. That side also has a slope. It's not perpendicular side to us because it's not straight to us. And this side also similar. So it has a slope. It has a slope. So that's why we cannot select this this side also. The only side is this here. Okay, so it's looking to us 90 degrees. So every size, every edges of the prism base is exactly as is. Okay, so it's not looking with angle to us. So that's why we select this view, and then on that view we are making a points. Okay, so here the corner points, yeah, another corner point, another corner point. Okay, so we refer. okay, so we define a point as this one is first point, and here we made the second point also, point number 2, and point number 3 here, and here the point number 4, which is intersected with pyramid side point, edge point, edge, and the prism edge is made at this point 4, and point 5. Okay, so point 5. We did a point. So now the task is to find dead points in other projections. Our task is to find another projection in other, in the top view projection and side view, the left view projection. How to find it? How to find it? So if you see here, in previous example, how we found that, we did a line. We did a line from the tip. For example, the green line from the tip. We did a line like this line, passing through the tip point, point O and point 6, and passing until it cuts a base of the pyramid. And we found that place, right? We found a point E and J. Okay, so that point. So this point can be projected in other views, other projections. How to do that? Just make a line. Okay, so line like this line, and then that will give you the point E here and point J here on the edge, okay, on the base of the pyramid. And then so this line, okay, so green upper green line can be generated in the top view also. So there is a tip. From the tip we can get a line. We can connect the tip point O and E point and generate a green line. But we have two lines. One is the front, one is the behind. So at the point 1, so point this point, okay, so point 1 or 6, where is that? That is the two bodies are having similar single point. So the first body is the prism, triangular prism, and pyramid has single point connection. Okay, so intersected point. So that point lies on the green line. Okay, so where is green line? So this line and that line are similar line. So that one is a front view, one is a top view, same line. So on that line, okay, so this lies on that line. So that's why we can make a projection of the point 1, okay, point 1 onto that line. So that is a point 6. So let's make another color, so purple. Okay, so we did a projection of point 1 into that line. So then we generate, okay, point 6 here and point 1 here, because we have two lines. So then same other points. Okay, so point 3 also can be created same way. Okay, so make a line and find that line's projection here and there, and then the point projection on that line, so point 8 and point 3. Okay, so then the only point 7 is can be found from that side. Okay, from that side, 7 and 2. So we are making a projection from point 2 to the right hand side. So, and we find point 2 here on the edge and point 7. So same like 4 and 9 and 4. So because that is on the edge. So then the distance of this one from the center up to that point, that distance is equal to this side. Okay, so that's the center. That's the center. So here. Okay, so you can do this with 45-degree angle line, and then make that point projection onto that, and then that intersects like this. Okay, so bends the line like this, and then find here the point here, point 2. For the point 4, same like here, point 4, and point 7 also similarly, same, point 7, and then point 9. Okay, so then connect everything. So but connect with first one and second one. So where is first one and second one? So first is here, second is here. Okay, so first one and second one next. And then second and third one, second and third one. 3 and 4, 3 and 4, and 4 and 5, 4 and 5, 5 and 6. Okay, so okay, 5 and there is a no 5 and 1, 5 and 1, 5 and 1 here. So that's a intersection of the entrance. Okay, so the penetrated shape of the prism and pyramid makes this kind of hole, the first hole. So on the outside outlet, okay, so that's the inlet. So outlet, how will be outlet? Same thing. The 6 and 7, where is 6? 6 is here and 7 is here. 6 and 7. So let's use another color. So green one. And 7 and 8, 7 and 8, 8 and 9, 8 and 9, 9 and 10, 9 and 10, 10 and 6, 10 and 6. So then draw the remaining shape. Okay, so the shape is in makes this kind of hole again. So the outlet. So and if you see from the top, the sum of the lines should be hidden, because if the shape is on the top, and so the sum lines will be on the bottom of that shape. So that's why we are making a hidden. Okay, so this line should be hidden. So hidden lines are made at the basically is this dash line. Dash line. That's that's outlet. Okay, so same way. Okay, so others this another side. So this side also can be done same way. Okay, so that's a way. That's a way. That's the surface of these bodies are flat surface. So we'll see later on the second order surfaces.